Beginning. Go ahead, Denise. Drop a line.
Hey guys, welcome back to our YouTube channel. Make sure to leave that like, comment.
And slap that subscribe button.
Yeah, slap it.
Alright, so polar coordinates. Let's get to this here. Objectives again, really quick like. They're there for you. You can pause the video if you want to look at them a little bit more. We've already talked about this here. Polar axis. Think about, no recycled paper. Where'd my recycled paper box go? Did you take it? No. Oh, someone took it? Okay, thank you. So again, I showed you guys the polar axis. It's this round looking thing that looks like rectangular, except it doesn't have little squares. It has circles in it. A polar coordinate will be given to you in the form of an ordered pair, except the order of this pair is radius, comma, the angle that you're looking at. So r comma theta, not a big deal. Of course, you do always start with your terminal side, which means that you're at technically 0 degrees, and you count how many degrees. Yes, someone made a fantastic point. Theta can be given to you in degrees, or it can be given to you in radians. So be aware of what you're looking at and what you're working with. Same thing happens too. If they give you the theta in the negative, you'd be going backwards kind of thing. So it also kind of works out on a rectangular, even though they have what's called the polar coordinate here. So 315 degrees. I'm just going to eyeball it if that's cool with you. It's probably going to be somewhere over here somewhere. Yeah? So that's saying that this is 315 degrees I've traveled, and the radius is going to be 3 units long. This is so difficult.
Somebody's watching your video.
Okay. Oh, look at that. I wasn't that far off. Yeah, man. It's still not correct.
It's like you're at like 320.
Alright, whatever. You get the point. Let's move on. Okay, so in this case, what is this asking us to graph? We're doing -2?
Yes.
Ooh, that's interesting.
Isn't this like split?
We're doing -2 radians. What's up? Okay, what's up? And you're at pi radians.
Oh, I get it. If you get it, your pi with pi is on the negative side. If you remember.
Where's pi?
It's on the left side.
Quadrant.
It's quadrant 2.
Right.
It's in quad 2. So quad 2.
No, it's in between quad 3. It's on the y axis.
Oh, no, I get it.
It's over.
Because it's positive, we're going to counterclock.
Over
Are
there.
we still debating?
Exactly.
It's on the x-axis, so it's going to be -2.
So, even though the angle was given to us correct, we're going to go in the other direction. Okay?
So you still go like that, but you're gonna flip.
We're still going to go this way, we're going to shoot the other
Yeah,
direction.
that's what I mean.
You can't see it very well, can you? Let me see if the next one is brighter. Nope. So,
Oh shit.
we are traveling to here, but actually we're going to go 1, 2. And there's my segment right here.
I'm going to write that down.
I'm going to go the other way. It's still pretty ridiculous. Yeah. No, this wouldn't be a right triangle. This would put me the opposite direction. So let's say I did 3 pi fourths, which is like maybe right about here, and it was -3. Then I'd go that way.
It'll be quad 1.
Technically, because I'm going in a negative direction. So the way I should have really written this, would it not be an equivalent?
Yeah. What?
Go ahead. I can't hear you.
Why is it not on that side?
What side?
Shouldn't it be in between the second quadrant and third quadrant?
You're thinking it should be here?
Yeah, because
Okay, so if I went pi, and then I extended my radius to be 2 units long, I traveled 2 units. I traveled a positive 2 units.
You have to go back.
Ew, disgusting. Why do you have to go backwards? Disgusting. Oh, so do we have to draw the like amount?
I said even if you get them backwards, you're going to go the other direction, aren't you?
Disgusting.
Fun times.
Like,
Yes, it's all to be the origin.
sticker got pushed up.
I'm upset.
So you really got to be careful whenever they give you a negative radius, and maybe something like 150 degrees.
If it was positive 2, it'd be right there.
It would be there. It would be there. Thanks. Thanks, Matt, for reading something so beautiful.
That's disgusting.
All right.
So much easier.
How about that? Try that. Think about that for a second.
So it's next Friday.
Yes, you are.
I just don't see it.
Got it? Where are we at? That was a cool little
So
dance.
we're gonna be at pi halves. 45 degrees.
Ow.
Negative pi halves.
My leg still hurt. My foot
Can I
still
say
hurts.
where it's at? So it's gonna be on the. Is it on the bottom line here? In between the third and the fourth, or the third and
Pi halves is at 90.
quadrant? What do you call
Oh
it?
yeah.
It's going down.
Right.
90 degrees this way, but then we're going back.
It's going to be on pi halves.
Oh no, I didn't get it.
Yeah, right.
Even though my angle is negative, my radius is negative, so instead of going downward, I have to go upward. Because they're both negative. What's up?
Yes.
They're just circles. Polars. And that's also not necessarily a rule, because you know how sometimes we have grid marks, and we designate them to be 2, 4, 6, 8 instead. So all the rules still apply here. I can designate by polar system that increases by units of 2 or units of 3. Okay?
That's pretty easy.
I know.
I am enjoying this lesson.
It's always enjoyable when it makes sense.
Exactly.
Don't know the rules, you can't play the game. Here is 5 comma pi fourths. Does everyone agree with that? We're looking for another representation of that. But it must be within 2 pi to 4 pi. So what's another way that I can express this? What was the name we called it at the beginning? No, I called it coterminal because it made more sense, because we talked about coterminal. They called it, it's like multiple sets. Multiple sets. So if I'm at 5 pi fourths, how can I represent this another way?
Isn't just a circle?
How about that?
Oh yeah.
Why? What's wrong with I can't even spoke. I can't even spoke.
As another way to represent it.
Well, they're looking for multiple sets. So you're looking for another one that is coterminal to that. Well, all I have to do is go around the circle one more time, don't I?
Yeah.
And then that's it. So technically this would end up being, what, 3 pi fourths?
Oh my god.
No. Is it?
No, because it would be.
Oh, I need a common denominator. So this would have to go to 8 fourths, so it would be 9 pi fourths.
Yeah.
So there you go. I represented it the same thing again.
It's the same thing as that.
How is that the same thing?
Because you just went in a
So-
circle.
Circle.
How many?
Oh.
I was gonna draw a circle for her.
Is that a 5 or a 3?
That is an 8.
That is so confusing.
Pi plus 8 pi.
No, the bottom one.
That's 9.
I'm sorry.
It is 5. Okay.
No, 9.
Wait, 9. You put an 8. 9.
Pi.
Oh, that's 8.
Yeah, I was confused because that looked like a 3. I think we should just end the lesson here. I'm just playing.
get done with this until Friday, spring
The
break.
quiz, oh, we didn't do it. So quiz too?
We can make a quiz. We could do it Monday.
But no, I'm saying I want it in quarter two.
You mean quarter four?
It'd be 6.3. 6.3. That'd be fine with
Okay,
that.
so as long as February is quarter two.
Unless you don't do your homework.
Hey, I'm not going to that.
Weird one?
Okay, contain yourselves, people. Oh, there it is. Ah, beautiful. Is this another one?
Yeah.
No, it's the same one, isn't
Oh,
it?
that's the same one.
Oh, again. We can also do the negative version of it by subtracting 2 pi. Yeah?
No.
Right? We just go backwards. I mean, none of this is new. I think we learned the harder way with trig, didn't we? Okay? So I'm going to move on if that's cool with you guys. I want to see what else we can do here. Bop, 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 bop. We already talked about the polar to rectangular.
Yes.
There's a slide for that. You're going to be doing... Oh, here's an easy way. If you want these formulas,
Oh, okay.
it just kind of makes sense, though, that you can derive them, kind of the way I did.
That should be at 64 right now.
If you want them as generic formulas, here they are. If you want to help you memorize there, we always associate x with cosine. We always associate y with sine. So they're there. Okay? So I'll continue. Okay.
Back. Why are you writing all of that?
I know. If there's some people that are that way, some people are more visual and we know what's going on. See Elijah not writing? Elijah's like, no, writing just makes me dumber.
Yeah, no.
What, you write it already?
I wrote one thing.
Because you didn't even want you didn't want it to begin with.
No, but Elijah does learn everything visually.
Yes, that's what I'm saying. Elijah's a
Elijah
visual
doesn't
guy.
even take notes and he gets like 95 something.
Because he's a visual learner.
I can't do that.
Wait, what are you
I was not taking things like this class.
Yes. I know he
I don't take notes in history. I don't even read the book. Somehow I still get a good grade.
Have you done Sunny Low?
Oh yeah, I just wanted the X to like.
Alright, here you go.
It's a D and higher.
Do this as a polar coordinate, please.
Do this as a what?
As a polar coordinate. Elijah, what's the answer?
It's the thing, it goes here, and then it goes out 3. It's on the X axis.
Oh, I know.
So what is it?
It's 3 0.
No, sorry.
Oh, the rectangle.
Negative 3.
That's a rectangular coordinate.
Oh.
Is that just 3?
What is it?
3 0?
No, it's not 3, 0.
It's negative 3 0.
You have shamed me.
Negative 3 0. I was right?
Yeah.
Hello.
You don't see it?
I
can't see it.
I
can't
see it.
What?
I'm rotating positive pi.
Yeah.
Put up.
That's here, correct?
X, Y, okay.
So now I need to draw a segment from the origin that is 3 units long.
Why is it?
Because it said 3.
X, okay.
So now I want the coordinates to this. That means it would be negative 3, comma, 0.
So cool.
See why?
Now you can sit there and plug them into your calculator, into your formulas, your x equals r cosine theta. Huh?
3. Why did it go that way instead?
Because it's a positive. You're just moving in that direction.
All this is telling me is where to rotate to. So I'm rotating to this point.
So it's a negative 1.
Yeah.
What is 0?
And then if this is positive, then I go in that direction.
For pi.
And if it's negative, then I would go the other direction. That's simple. What's up?
Makes sense, my
Okay, here you go. Thank you. We'll use the universal sign for I have a question. Go ahead. Which one? This one? It is. This is the rectangular form of this polar coordinate. I really can't. This was me doing it visually. If you want to do it algebraically, throw that in your calculator. It'll probably say negative 3. No, actually it will say negative 3. Do it. And then to get the other one, for y, you'd go y equals 3 sine pi. Now, if you want to see it,
Oh, I get it.
if you want to make the connection with what we were doing before, why is it not all going away? You're not smart. Here is my angle, correct? And if I think about cosine itself, I know that here, the cosine is a -1, and that sine is 0, correct? So if I take 3 times the cosine value, there's my -3 again. And if I take 3 times my sine value, well, what's 3 times 0? There's my coordinate in rectangular. Okay? No? No what? Okay. How about that? How about that? So it's pi 6. It's 30-degree angle.
Yes.
Negative.
So it's gonna be 3. Oh, this one's kind of gross.
It's like down here.
No, it's pretty gross.
I have a theory.
No, it's over here.
210 degrees.
It's in quadrant 3.
Yeah, quadrant 3.
Oh, never mind, I was right. Wait, how is it in quadrant 3 if you're going 10 over here?
Yada.
Where's pi 6? It's here, correct?
Isn't it 8 and 6?
So there's the angle, but this is a -10. So instead of going that way 10, I go that way 10.
I got it. I got
Why
it.
are we going that way?
Because it's a -10.
But if whenever they're positive, we're going that way. Why are we going that way? They're
You're
negative.
moving in
The
the
opposite
opposite
way.
direction. So if you're on this side, you're moving this way, so you're gonna move that way.
Is it?
So if you're moving this way, then they're gonna move this way. So look, on
So it would be. So this would be.
I just used Pythagoras theorem in my head.
Yes, because it's in
Good.
Radical 3 over 2,
went up.
I really want to.
1/2.
No, we went back one.
So then I would have -5 radical 3, comma,
We're already going negative. Look.
-5.
We're going negative, right? So now since we're negative, we're going up.
Using your method. Let's use the calculator method, yeah?
Yeah.
Yeah.
This for the people that-
That means that x would equal -10. No, we could just do 10. No, let's do -10. -10.
Cosine.
See,
Cosine pi over.
Where'd the -10 go?
it's from there.
Oh, we gotta do that.
Cosine
Why did it do
pi 6. Someone calculate that? Oh, here's my calculator.
Just have to cosine.
Now, here's the deal. Let me.
No.
negative 9.999?
What is it? What is -10?
Yeah, negative.
Cosine.
10 by 6. You get negative 9.999585244. So wouldn't that just be -10?
But you're in degrees.
Oh yeah. and
You
it's
fool.
radians.
Simplify
I mean,
pi.
crap.
Negative.
I got negative 8.66.
Booyah!
I applaud you.
What are you doing? Stop it. That's weird. Stop it. That's a little weird.
I'm sorry, no.
Okay.
Which part?
Why is the radius is 2?
Oh yeah. Why is the radius 2 and not?
No, it's not. No, it's not. This is me using the trick that I know to make this easy for myself.
Oh, the pi.
Okay? Realize this. Realize this. Realize this. Let's get rid of this, okay? Actually, let me start again. Let me show you my thought process because you can just throw that in the calculator. It's going to give it to you, right?
Oh yeah.
But I want you to understand what's going on. Very important. Okay. So, Catherine, pi 6 is right here, correct? Pi 6. But because this is a -10,
What?
I'm going this way, correct?
Wait, why?
Yeah, yeah,
Why
just roll pi third.
I don't know why I did it. Sorry, pi 6. Okay? So that's pi 6. So technically, yeah, my radius is a negative 10. But in my mind, here's what I'm doing. Pi 6 is a 30-degree angle, isn't it?
Yeah.
And I know that it's going to be a 1, 2, radical 3. So if I want the coordinates of this, then I'm going to do cosine, which is radical 3 over 2. Right? And technically it's a negative. Okay? And then my sine is a negative 1/2. Okay? So in my mind, it's this unit circle stretched out by 10. And so I just multiply them.
All sides were divided by.
And I just multiply them by 10.
Oh, it was like if you think about it, like all sides could have been divided by 5, and it's like a 2, like so. It would have been like 5, 10, and it's up.
Oh, well,
Wait, what? I missed the whole 2, 1.
do you remember when I gave you? Shh, thank you. The question was, what if I didn't convert this to a 2, and I just went to a 10, and I left it as 10? Sorry, I left it as 10. Well, here's what I know. I know that this is still a 30-degree triangle. Therefore, it must follow the proportions of it. Here's 30, here's 60, here's 90. And I told you guys this is x, this is 2x, and this is x radical 3. So go ahead and just plug in a 10 for those. So that means that this is 10. If this is 10, that means that this is 5, and this is 5 radical 3.
Okay, so
Correct?
where you-
Negative, negative. Okay. Now let's do that. What is the cosine value? What is the cosine? It's still going to be.
1/2.
It's still going to be negative 1/2 on cosine, and this is still going to be radical 3 over 2 negative. So it's still going to come back down to this. Just multiply it by your 10, and then you're good to go. Now I'm doing a lot more math than you need, don't I? Aren't I?
Yes.
Because I want you to make some connections with some of the stuff that we've been doing. Maya? 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 Can you join us, please? Thank you. I didn't have to do any of this math. You already got the 2 formulas. Take that radius, multiply by the cosine, or the sine of that angle, and you're good to go. That's simple. But I'm making some connections, so you can see that it all just kind of ties together in the end, doesn't it? Okay, let's move on. I don't want to run out of time. Blah, 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 blah. Oh, look, mine are exact. Yours are not. Ha, ha, ha. Sorry. Converting a point from rectangular to polar. From rectangular to polar. They're going to give you the distance formula, guys. And I don't know why the guy that invented the distance formula got any kind of props. Because all he did was steal Pythagoras' work.
He stole it?
I'm saying he stole it. Yes, stole it.
He's still alive?
Because this is what happens. What does Pythagoras' theorem say? A squared plus b squared equals c squared, correct?
That technically.
That means that if I have some triangle, the legs are going to square up with the hypotenuse, correct?
Yes, sir.
This is the radius. That is the radius. So, I'm going to switch out for radius. And I think we did this with the circle as well, didn't we?
Yeah.
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 And A is technically x. B is technically y. So how do I get rid of that r? Square root both sides. And there you are, friends. The distance formula is just Pythagoras' theorem. So if you're going to go the other direction, then all you have to do when they give you a rectangular, okay, let's do that actually. Oh, at an angle. Got it?
No,
No, don't got it.
Stop.
Stop.
That's good? Wait a second.
Where did it go? One.
What did it go?
Okay.
We're good? Okay. One more time. We good? Okay. This is a rectangular coordinate. This rectangular coordinate is telling me that I'm going to move 1 unit this way and then radical 3 units this way, correct? So this is technically 1, negative radical 3. Now I can sit there and I can do the tangent stuff because I want theta. I need theta, don't I, for my wood bobber? So I can say, how do I ask for an angle if I know the ratio? Tan inverse, negative radical 3. Don't tell me what tan inverse negative radical 3 is. What is it?
Wait, did I tell you what
It is. You're correct.
Oh wait, is this in radians?
Yes. It should be a 60. Yeah. 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 Here's where you can become a jerk. Here's where you can become a jerk. You can say this is negative 60 degrees. You can tell the reader, hey, this is, what would that be? If this is 60, you could say 120 degrees, right? You could tell them, hey, that is negative pi thirds. Or you can tell them, hey, this is 2 pi thirds. And then find all the corresponding distances for those. What? Because I would be going this way. And then I would just say negative radius in that case, and then negative radius in this case, right? Now how do I find that radius? 1 squared plus negative radical 3 squared, and then take the square root of that. So I've got 1 plus 3 is 4, square root of 4 is 2. So 2, 2, 2, 2. And there are 4 different options to give it to me in polar coordinates.
What? Wait, you lost me.
I know, huh? Sorry.
Back up for you.
Back up to where?
Back up.
I just did Pythagoras theorem. 1 squared plus negative radical 3 squared. Did I do that right, guys?
Yeah.
Is equal to c squared, or distance, or radius, whatever you're going to call it. So this is 1. This will be 3 equals radius squared. This is 4. Square root of both sides, you get 2 for the radius.
Wait, it wouldn't become negative 3, right?
Huh?
It wouldn't become negative 3.
Okay, so
No, because negative makes
where did you get 60?
negative 60. You can do that from your tan inverse. You can get it from here.
Oh, that would just have to be a degree.
Or I can think about, oh, 1 radical 3. I know this triangle. That's a 2. I'm working with a 30, 60, 90. And therefore theta is 60.
in degree mode. We're in radians.
That's all we have to do.
I'm only asking.
And it's only asking for the radius?
No, all it's asking for is convert this rectangular into polar coordinates.
And then would you just be adding like,
Hold on. How'd you get this?
I did a lot of work there too. Sorry. Where'd I get what?
So why did we get,
Go ahead.
why did we like look for the radius and the two radius?
Because how do I give you rectangulars as a polar? You need radius, and you need the angle I travel.
so would you just be doubling?
And where'd you find the angle?
You were just doubling.
Because
Do
Oh.
it again, would it be like negative 180?
Oh, negative.
No. Let me show you all these, okay? This one is negative 60 degrees, positive radius of 2. That's this version of it.
Right?
I also went with, hey, travel 120 degrees and go the opposite direction. You see that one? Or I can convert this into radians, and this is the equivalent in radians for this one. Mika, you're good at your processing.
I don't understand how you got the 120.
Okay?
Because that's
You understand how I got 60? You understand how I got 60? Okay. So here is 60 degrees. Let me continue this line this way, correct? That means that vertical angles are 60 degrees. So if this is 60, how much is that?
Tan inverse.
Good? Cool. Anybody else? You need some solar energy.
Don't move.
Look at all these slides for all that.
Wait, can we go through this?
You want to go through them? You're such a geek.
I just want to see, like, maybe.
Maybe it makes sense? What?
Yeah.
How dare you? How dare you?
I really don't understand what it is.
No? You are. Oh, it did work. Yay. Alright, first thing you need is your angle. You can get that from tan theta, right? Or inverse or tan inverse theta? Let's see here. So there, you're cool with that? That is 1, -3, correct?
Okay,
Okay. We need to find r, the radius. You can do that with Pythagorean's theorem. We got a radius of 2. Okay? So this length is 2. Now we need the angle. And we can ask tan inverse. Do they do tan inverse?
No, they just did the tan.
Okay, that's ridiculous, but there's your tan inverse. That means that theta, this, is 5 pi thirds, all the way around.
where'd they get?
Oh, there's 2 more I didn't get, huh? I could have done the 5 pi thirds version.
Yeah, you could have.
I could have.
I
Yeah.
was thinking about that, but I was like,
But you didn't say that. You could have contributed to the confusion.
yeah.
Sorry.
Because it went down, you could like.
Instead of just the negative version, and so remember the 60 we got? Goes this way? I could have also done the positive version all the way to here.
Disgusting.
So I actually had 4 more options I could have given you. Just to drive people crazy.
Just to aggravate.
Torres, you good still? That's it. You just put those 2 together. I think that's enough for you. Okay? The other stuff was just us 3 playing around with all the possible ways I can show you this to you. Okay, so do you see what's going on?
Yeah, the angle.
This is 2, and this is 5 pi thirds. Right? What one? No, that's not the same one. Sonny, this point right here, do you see it? The coordinates are 1, negative radical 3. The 2 is that guy. Shh, quiet, please. Thank you. How do I know what's saying?
How do you know that the coordinates on the right were like the thing?
Because they told me that that these were rectangular in nature. Rectangular. That means x comma y. If they told me they were polar in nature, then they're giving me r comma theta. Ah, we missed 4 different chances. I feel like I'm not going to get that opportunity back.
It's rewind time.
If I could have a time machine, I'd go way back further than just probably high school. Do high school better? Everybody would.
You wouldn't know any of Rosie life would be so sad.
That's very true. And I would have knew my wife, and I would have my kids. Ooh. Whole string theory thing going on, huh?
See, once something horrible and tragic happens in my life, then I would go back. Usually the
It's like I would just. What? No.
conspiracy theory. He's like, don't even get me started.
Yes.
Oh, what is this? Equations?
Oh, it's converted from rectangular to polar.
Oh, I was like, it would be like little basketball face.
Wait, what?
Thank you. Wait, what? The question was, because now you have to take equations and convert entire equations into polars, right? Yes.
You have to find like the x-axis.
We already gave you the conversion. Guys, when I gave you polar, where do you find x at? Is it not at r cosine theta?
Yeah.
Is that not an X?
What the hell was that?
Did someone finally snap?
Like a math test.
And I have it on YouTube.
It was so. Was that like a yell?
Yeah.
Was that for me? I think I'm gonna stop this right now, okay? You want to finish this tomorrow? You need to finish tomorrow, or are you good? Okay. I don't want you to come back tomorrow with a ball spot, right?
Can I come back tomorrow in a straight jacket?
This is good times. Where can I find Y? How can I find Y?
R sine theta.
R sine theta.
Is that not a Y?
Yes.
So you can just plug it in.
Yeah, just plug it in. So 3R cosine theta in this case minus R sine theta is equal to 6. There's your first steps, right?
Wow.
That's how it felt as a person in school.
Oh, there it is. All right, cool.
I was like, that's why I got confused. I was like, what happened?
Oh, is this what confused you?
Yeah, because I was like, wait a second. I didn't get a chance to process it.
But you're good?
Yeah.
Okay. Oh, excuse me, Mr. Chair.
The day is just not great.
I'm just glad I didn't die. Oh my God. We got the funny gas out today? Okay.
Oh, they divide that stuff like that.
Wait. Okay, no, it's not, is it?
They both have R in common. We're factoring that out. So here's R for our polar coordinate business. So there's your formula for 3x minus y equals 6 as a polar equation. Here is where the TI Inspire outshines
This little.
this 84. Is you can graph polar. I think. Let me. I think 84 might be able to. Yes. Mode. Go over to polar. Do that real quick.
You have a polar mode in here?
Yeah.
It's like under
Oh, I see it.
And then when you go y equals, there's no more y equals. Now it's R
R1.
Oh,
equals.
that's how they did it.
Oh, so then you just plug that into there.
Move.
So then
Sorry.
we do math, this. Go mode, and it's over right there. See where function is at? And you see where parametric, you go all the way over to polar. 6 over x. Oh, it's not that theta by then.
Wait, let's like window this to like
What are you doing?
negative 10, positive 10.
You're harassing my computer.
What is that?
It does it better.
Wait, where am I going?
Let's change it to a polar.
Yeah, it's so stupid. No, freaking take it off my laptop. Did you? Yes, this is really weird looking. That's all it did.
What to do?
You got that little extra window.
So what's really cool about this is that now that you have polars, you can start making all kinds of very beautiful graphs on Desmos. Like people have made all kinds of crazy artwork.
No, there we go. That's a lot better. You did zoom fit, but that's just.
How are we on time? Oh, I got 2 minutes.
Yeah.
All right, laughing way too much. Let's stop this.